We have two different kinds of changes that we make to parametric equations. First thing we can do is reverse the orientation, change what direction the arrows are going. Now, usually, naturally, your arrows will go from left to right because that's how we usually think of graphing things, from x is negative to x is positive, or if it's like a circle and ellipse, we're going counterclockwise. However, we can change the direction of those arrows by replacing every t with a negative t, and that includes the bounds on t. I'll show you what that means in just a second. And that will change the direction of the arrows. The second thing that we do is shift a parameter. And what we do here is we're going to replace every t with a t minus c. And c is how much we want to shift it. And that minus c will shift the parameter ahead c units. So let's say t is like on a line segment, every t goes from 0 to 1, but I actually want t to go from 1 to 2. So I want to add 1 to both of my t values. So I would replace every t with a t minus 1, and that would move it ahead 1 unit. So those are our two kind of adjustments that we make. Let's try this on example 9. I've already visualized what we got here. We have y equals x squared. Here's my parabola. I'm starting here at 2, 4, and I'm ending at negative 1, 1. Now, first thing that you will notice is we're changing the orientation of the arrows. Number 1, because normally our arrows would go from negative 1, 1 to 2, 4. They normally go from left to right. So first thing we're going to do is reverse the orientation of the arrows so that they go from right to left. Then the second adjustment it's asking us to make is to shift the parameters so the path starts at t equals 0. So we're going to have a time delay or a parameter shift. So these are the adjustments I'm going to make. Now before I make those adjustments, I should probably list what this parametric equation is. So we have y equals x squared. Use the rules we learned in the last video. Since this is a y equals equation, we do x equals t, y equals t squared from, and now we'll just list the x values, from negative 1 up to 2. So this right here is currently describing this parabola right here. However, as we said before, we're starting at negative 1 and going up to 2. So the first thing I want to do is reverse that orientation. So I am going to replace every t in this problem with a negative t. Including the bounds. So that means all the bounds, I'm going to divide them by a negative 1. Change the sign on them. So now this is going to give me x equals negative t. For the y equals negative t squared is still just t squared, but it's from 1 to negative 2. But we always list it from least to greatest. So that means I'm putting the negative 2 here and the 1 there. And this is going to give us this same exact shape, but now it's changing what direction the arrows are going. So the arrows are going to start up here and go this way. So that right there is changing the orientation. Now we need a parameter shift because it wants the path to start at t equals 0. Right now the path is starting at negative 2. So I want a parameter shift right 2. I want to take that -2 to a 0. So if I want to move right 2, or I should say ahead 2, according to our rules, I would replace all my t's with a t minus 2. So replace all of these with a t minus 2, and that's going to shift my time ahead 2. I know those signs are kind of opposite, they're a little wonky. So this is going to give me -t plus 2 and t minus 2 squared from 0 to 3. And now, once again, you could make a t-table and graph this. It's going to be the same parabola shape, but now my arrows are going to go this way, and I'm starting from t equals 0 like it's asking me to. So that is an example of our 2 different adjustments we make. We have reversing the orientation, and we have shifting the parameter. So let's try another example. Here we have a 2-part path. It's going to start at 0, 0, travel along a line to 3, 4, so it's going to travel that way, and then travel along a line to 5, 0, that way. That's the path we want. So let's just start by doing this as 2 line segments. We have our first line segment that goes from 0, 0 to 3, 4. And then we have our second line segment that goes from 3, 4 to 5, 0. So we're just going to use the rules we learned in our last video to make 2 separate parametric equations. Both of them are line segments using our line segment rules. So in this one, this is x0, y0, x1, y1. In this one, this is x0, y0. This is x1, y1. So just make 2 completely separate parametric equations for our line segments following the rules we learned in the last video. So what I'd like you to do is pause the video, try to follow those rules to write out what these would be, and then come back to check them. Here's what I got. You can check your work against mine. First line segment, I got x equals 3, t, y equals 4t from 0 to 1. Second line segment, I got x equals 3 plus 2t, y equals 4 minus 4t, also from 0 to 1, because those are just how the rules work. So this first line segment is perfectly fine. That is our answer, that works. However, the second line segment is happening at the same time as the first line segment. And that's a problem, because I want it to travel along this line, then travel along this line. I want it to be this one, then this one, not occurring at the same time. So it looks like what I need is a parameter shift where I'm going to shift this one to start where this one ends. So I need to shift it ahead 1 unit. So we know that means I'm going to replace all the t's with t minus 1. And that will shift these ahead. So t minus 1, t minus 1, and that's going to shift these ones ahead. So let's see what I get. 3 plus 2t minus 2, 4 minus 4t plus 4 from 1 to 2. And if I simplify that, I get 2t plus 1 for x, and negative 4t plus 8 for y from 1 to 2. Now, this is going to give me this same line segment, but notice it's going to happen after the first part. So it'll happen this part, then this part, because of how our t's are defined. So that gives you a couple examples of our two adjustments, reversing the orientation, shifting the parameter. We have one more example to do today that will summarize pretty much everything. We're going to have 3 different adjustments that we're going to make. So I'm going to do that as its own video as one last problem for this lesson, and then you're all done.